Okay, this section is still part of Domain 4, Communication and Network Security. Secure Network Components, Section 2. Okay, so we're dealing with Section 2, 4.2 objectives. One of the areas we're going to deal with is around the network components, and we've got 5 main objectives. The operation of hardware, transmission media, network access control devices, endpoint security, and content distribution networks. Okay, in this objective, we're going to talk about operation of hardware. So as an overview, security is from a network. This is basically around a network component level is where we're at. And there's the intranet, which is your private internal network, and your extranet, which is your blend of the intranet, which is your internal network, and the internet, which is the World Wide Web. And that's the whole purpose of the extranet. And so you'll see this quite frequently, people referring to them as the internet, the intra and the extranet. The demilitarized zone, which is typically you'll find that separates your business network from the internet, is found on the perimeter. And this is where many applications that require internet access or internet communications will sit within the DMZ. In some cases, there'll be we call proxy servers, which will be sitting in the DMZ where someone will log into, and it'll dump them back into your network. But it's the gateway in and out of your network. In many cases, there's firewalls that are residing within the DMZ, but that's the piece around the process, or around your business network and the internet. Now, if you have a process network that deals with manufacturing, you probably have a DMZ internally to your environment, which separates the business network from the process network as well. Then you can also do segmentation, and this is around virtual local area LANs. And what this comes into is your firewalls or other networking type devices. You can set up a VLAN, and this is a network that is its own little segregated piece of your network that is tied off of some hardware equipment, and that's the segmentation piece, and that's where your virtual local area network is connected through segmentation. Now, how does this all begin, and what are the different transmission types? So back between the 70s and 80s, there was the coaxial cable. And I remember as a kid, and again, this really dates me because I'm just an old crusty guy that used to be around when rocks were soft and dinosaurs roamed the world. But there was coaxial cable that used to connect locations. My dad did this. He was pretty bleeding edge, actually. He would have cables that would go communicate. Computers would be from one room to the next, and these cables would be spread out over the floor, and they were just a regular copper cable that would go and connect computers. Then the twisted pair of the category Cat 5 and so forth took over, and then from that point was that it became an issue where the twisted pair is much better transfer rates than just a single coaxial cable. Now with coaxial, they did have some problems. It had limited flexibility. I do remember you couldn't really move it around doors. It had some challenges with that. Max deployment was between 185 and 500 meters, and you had to have a terminator on the end of the cable, otherwise it wouldn't work. So if you had it in rooms, specific rooms that weren't being used, you had to have a terminator on the end of that cable. The next one is baseband and broadband, and this is the next generation from coaxial. The maximum speeds and per these cable types was kind of this way. Your 10-base-2, which was typically what went through in many places after the coaxial moved out, was about 100 megabits or about 10 megabits per second, which for that time was pretty fast. Then you have the 1000-base-T, which was 1 gigabit per second, which is typical of what you saw, a few years back, where you could get 1 gigabit per second was pretty good throughout your environment. Your baseband was a transmit only a single signal at one time, and that's how the baseband worked. So a signal would go out and the signal would come back only at one time. Broadband, which would allow you to transmit multiple signals at the same time, which is really beneficial, especially as you have all this communication force. It speeds the things up quite substantially. It's not this send, receive, send, receive. There's a sending and receiving basically at the same time. So that's where the baseband and broadband kind of roll. Then came the twisted pair, which we kind of talked about just previously with the coaxial. It's very thin and flexible cabling, and you can bend it, you can put it anywhere you want. It's basically a twisted group of very small wires that are set up to move through, that are kind of twisted together. And you can put foil. There are versions of this that have foil around the wires for shielding, and this is called STP, shielded twisted pair. If there's no foil, then it's unshielded twisted pair. Now, so keep in mind that if you have the shielded piece of this, then now it's not nearly as subjective to getting transmission issues with it. Whereas you have the unshielded twisted pair, it can run into some transmission issues where something will transmit next to it and can cause disturbances and cause potentially loss of data. Now the cable naming kind of works out this way. Cat 1, when it first came out, was voice only. Okay, there wasn't a whole lot because it was basically one bit of transmission. There wasn't a lot of data that was going across that. And when you consider the days of the old telephones with voice, it was just you transmit, it transmits back. It's just your voice transmitting over a wire. Then it went into Cat 5, which was 100 megabits per second. And I remember when Cat 5 was the bomb, right? It was everything. If you could get 100 megabits per second, you were smoking. Now there's up to Cat 7, which is 10 gigabits per second. And that's just amazing. But what you also saw is I actually, in my old house, wired it specifically for Cat 5. And now that wireless is so good, you don't really even need to do any of that. Now, there's key problems with deploying this. It's if you use the wrong category, you can put yourself in a situation where you spend a lot of money and you get really poor data transfer rates. Because if you're trying to do it cheap and then you go, hey, I'm going to put in Cat 5 and you need Cat 7, then you put it all through your environment and you go, oh, crud. Now you're limited specifically to 100 megabits per second. Deploying distance beyond recommendations. If you do that and deploy it, you will have attenuation. You will have loss of data transfer. And then using UTP in highly interference areas. Again, unshielded twisted pair. If you're going on the cheap and you go, I don't want to spend the extra money, and you have interference areas, well, then you wish you would have put in shielded twisted pair versus UTP.